Let's go over to the solutions to the compounded interest exercises. I'll remind you what the future value with compounding interest formula looks like. It's S, your future value, equals P, your principal amount, times 1 plus R, your interest rate, over M, number of compounds per year, all raised to the M, same thing, number of compounds per year, times T, number of years. What present value will amount to $275,000 if invested at 6.4% compounded interest monthly for 18 years. So over here, let's look at all these variables we have. We have S, we have P, we have R, we have M, and we have T. So I listed P, S, R, M, and T. What do we know? P is what we're looking for. We want that present value, how much we stick in today. S, your future value is $275,000. R, your interest rate is 6.4%, which converted to a decimal is 0.064. The number of compounds compounded monthly is 12 times a year, and the number of years is 18. So we can plug in S, R, M, and T, and we'll solve for P. Take it slowly when you're doing these calculations. Don't try to do too much in one. So I did the 1 plus 0.064 divided by 12, and save your rounding for the very end. Write out as many decimals as your calculator gives you. If you round too soon, you could be off by a couple of pennies, a couple of dollars, even hundreds of dollars. So I wrote out the entire 1.00533333333. And then 12 times 18 is 216. Next step, I took this 1.00533333333 number and I raised it to the 216th power. And again, I wrote down as many decimals as my calculator gave me. To solve for P, I will take 275,000 and divide it by 3.15484344, and I get 87167.55846. That's P. That's my principal amount or my present value. So in order to have $275,000 in 18 years, I need to give $87,167.56 today. Grandparents want to give their granddaughter $20,000 for her 20th birthday. How much do they need to invest on the day she was born if they found a bank with 4% interest compounded continuously? I remind you of the formula for compounded continuously. We refer to this as PERT. Your future value S is equal to P, your present value, times E, that natural base, raised to the interest rate R times time T. So what do we have? We have S, P, R, and T. So I wrote them all out, S, P, R, and T. And let's fill in what we know. We know that they want $20,000 in the future, so that's S. We know that they want it in 20 years, so that's T. The interest rate they found was 4%, so that's 0.04. And we're looking for how much they need today. So we're looking for this present value. So plug in what we know, 20,000 equals P e to the 0.04 times 20. Figure this number out first. E raised to the 0.04 times 20 is 2.225540928. It's important that you save your rounding until the very end. Divide 20,000 by this number and you get 8,986.579284 is your P. Rounding to dollars and cents, these grandparents will need to invest $8,986.58 today. And let's look at C. Suppose you invest $10,000 into a savings at 3.5% interest compounded continuously. How long will it take the account to grow to $20,000? Compounding continuously, that's the PERT one again. So we have S, P, R, and T. I wrote it all out here for you. P, the principal amount, we're investing $10,000 today. R, the interest rate is 0.035. S, the future value is 20,000. T is what we're looking for. So let's plug in P, R, and S. So 20,000 equals 10,000 e to the 0.035 T. Divide both sides by 10,000 and we get 2 equals e to the 0.035 T. Notice where that variable is. The variable I'm looking for is in the exponent. In order to solve an exponential equation, we're going to need a logarithm. So we can take the natural log of both sides. You can do whatever you want to an equation as long as you do it to both sides. So I took the natural log of 2 and the natural log of e to the 0.035t. Now look at the property of logarithm here. What you're taking the logarithm of is being raised to a power. You can bring that power out front. So we have the natural log of 2 is equal to 0.035t times the natural log of e. Remember, the natural log of e is 1. So this actually just goes away. Divide both sides by 0.035, and we get 19.8042056 is t, or we can see that it's going to take it about 19.8 years to grow to $20,000. That's it for these exercises.